Myself Khushbu Kapoor. Welcome to my channel Exotic Chemistry, where the mission is not only 100% marks but also 100% knowledge. Today I have chosen the topic of atomic radius. What is the trend in the atomic radius as we move down the group and as we move across the period from class 10th, chapter number 5, periodic classification. In my previous video I had already explained you about how to determine the group and the periods. Then I had told you how to learn the periodic table, and today I am going to tell you about the trends, how you are following the trends, that as we are moving down the group and as we are moving across the period, what will happen to the atomic radius. Okay, let's start. Atomic radius. What is atomic radius? Atomic radius is basically the distance from the nucleus to the outermost shell. To the outermost shell. Okay, this defines the atomic radius. Okay, now as we are moving down the group, friends, you all are familiar that as we move down the group, the atomic number is going to increase. So if atomic number will increase, then obviously the number of shells will increase, and if the shells are going to increase, then the distance from the nucleus to the outermost shell will increase. So down the group, if we are moving down the group, then there will be an increase in the atomic radius because of the increase in atomic number or because of the increase in the number of shells. Okay, let's see how. See, in the first group, if you are moving the first group, lithium, sodium, potassium, I am going to tell you about this. Its atomic number is 3, sodium atomic number 11, potassium atomic number 19. See, lithium, electronic configuration 2n1, sodium 281, potassium 2881. So, as we are moving down the group, the atomic number is increasing. That means if the atomic number is increasing, that means the number of shells are also increasing to accommodate more electrons. Here we are having 2 shells, Kl. Here we are having 3 shells, Klm. Here we are having 4 shells. Okay. So if we are studying that the distance from the nucleus to the outermost shell, here we are having 2 shells, now 3 and now 4. So as the distance from the nucleus to the outermost shell is going to increase, definitely the atomic radius will increase. Fine. But as we are moving across the period means, suppose I am taking the 3 examples of nitrogen, oxygen, fluorine. Atomic number 7, 8, 9. If I do the electronic configuration, 2 and 5, 2 and 6, 2 and 7. So, what will be the charge of the nitrogen atom? How many electrons does it need to complete its octet? Obviously, it requires 3 electrons. So, it will, after gaining 3 electrons, it will become N3 negative. Oxygen, it needs 2 electrons to complete its stable octet, or you can say to attain the noble gas configuration. It will become O2 negative. Fluorine, F negative. So, when we are moving across the period, in that case, the nuclear charge is increasing. See, the nuclear charge is increasing, and across the period, why nuclear charge is increasing? Because the pull of electrons towards the nucleus is increasing. See how? Here there is a pull of 5 electrons towards the nucleus. Okay. Now here comes the pull of 6 electrons. Here comes the pull of 7 electrons. If the electrons there are 7 electrons pull towards the nucleus, then definitely the distance between the nucleus and the outermost shell is going to decrease. If this is a nucleus and we are having in its outermost shell, we are having 7 electrons. The nucleus is going to attract those 7 electrons, and because of that reason, there is a pull of electrons towards the nucleus is going to increase. And if the electrons will come closer towards the nucleus, then definitely the size is going to decrease. See, what I am going to tell you is, just think it once again. Across the period, the nuclear charge is increasing. And if the nuclear charge is increasing, this means that the number of electrons are increasing. And if the electrons are increasing, definitely the nucleus is going to attract more and more electrons towards itself. And if the electrons are coming closer towards the nucleus, obviously the distance between the nucleus and that valence electron will decrease. As a result, if we are moving across the period, the size will decrease. But as we are moving down the group, size in the sense here, size basically refers to atomic radius. Okay. Down the group, the atomic radius will increase because the numbers of shell are increasing, and across the period the size will decrease because of the increase in the nuclear charge. I hope this concept is quite okay with you. I hope you have understood this concept. Now in the also there is one more topic. It is the last topic of this chapter, that the placement of metals and non-metals. See, metals are generally those which has a tendency to donate the electrons. Means after donating the electrons, they achieve the noble gas configuration. So group 1, group 2, and in group 13, there is exception also. In group 13, there are elements which have a tendency to donate the electrons. Okay, so the elements which are present on the left side of the periodic table are normally metals, while the elements which are present on the right side of the periodic table, that is group 15, group 16, group 17, that in that case they have a tendency to accept the electron to attain the noble gas configuration. So they are basically non-metals. Group 17, they are also called as halogens. Halo means salt forming. The 17 group elements generally have a tendency to form the salt, like NaCl. They combine with any metal to give the salt. And the noble gases which are present in the 18 group, which have the octet complete with the 8 electrons except the helium, that is having 2 electrons in its valence shell. Fine. Then if we are what I am taking about the metallic and the non-metallic property, na? Metallic and non-metallic property. Fine. Metallic property, the elements which are present on the right side of the periodic table. Right side of the periodic table are called metals, and the elements which are present on the right side. Right side, non-metals. Why non-metals? Because they have a tendency to gain electron. They have a tendency to lose electron. And in group 14, exception of the carbon, we are having silicon also, which is a metalloid. Okay, which have a tendency, which has a property of both metals and non-metals. Okay. And the last point is the metals which are present on the left hand side, they normally give the basic oxide, and the which are present on the right hand side, they normally combines with oxygen to give acidic oxide. So such type of questions are mainly asked in the board exam also, that what is the place of metals in the periodic table, where do you keep non-metals in the periodic table, which type of oxides are formed by the metals, which type of oxides are formed from the non-metals, name the metalloid. Okay, so I had already explained in my with the help of this video, you will get the answer of every questions. So I hope you have liked my video. Don't forget to write your comments, and please hit the bell icon so that you will not miss my next video. Thank you for watching.